Hi and welcome back. So not all the manufacturing processes works continuously on 3 shifts, 24 hours per day. Sometimes we have to add a work schedule. For instance, because we are just working between 8 o'clock in the morning to 5 o'clock in the evening. So we need to introduce work schedules in order to model the server in a correct way. So now we're going to have a look on how you do that. And in order to explain it in a more simple form, we're going to create a very simple model of a process. So we drag and drop a source into a facility view. We drag and drop a server, and we drag and drop a sink. And of course we connect them using the classical paths, like this. So now we don't want the server to work 24 hours per day. We want the server to work exactly between 8 o'clock in the morning to 12 o'clock for lunch, until lunch break. And then again from 1 o'clock in the afternoon to 5 o'clock in the afternoon again. So in order to add our schedule, we have to access the data window that you find here, just on the right hand side of the facility view. You click on data, and then you click on work schedules. We are presented here with an item which is called standard week. A standard week is composed by 7 days typically, and every day can be specified in different ways. And by default, SIMIO uses what is called a standard day, which is typically an 8-hour working day, which is attached to Monday, Tuesday, Wednesday, Thursday, and Friday, while Saturday and Sunday are typically empty. So, the work schedule is based on different types of weeks. So we can have standard weeks, or we can have particular types of weeks, for instance, maybe during summertime. So if you have a look at a standard week, we have also something that is called a workday exception, meaning that particular days of the week might be an exception just because they are like bank holidays or particular occasions for the company. As you see, a standard week is composed, as said, by standard days. So we can see our standard day look like a little bit down here. So if we click on plus, we see that a standard day in this model starts at 8 o'clock in the morning until 12 o'clock, and then from 1 to 5. It's exactly what we were looking for, and this is very good. We can also define something different. We can also define maybe alpha day, and this could be probably even applied to Saturday and Sunday if you have, for instance, a very high volume of work that we have to complete. So we defined another type of day, and we call it half day. So we define half day and then simply click on plus. And here we can define again the start time for the half day and the end time. So I think the start time for the half day could be 10 o'clock in the morning, and we can decide to work only for 4 hours up to 2 o'clock. Very good. So now we can associate this half day, and we can also give a description here if we want. But most importantly, we can associate the half day, for instance, to Saturday and Sunday. So we can simply go here, click and select half day for Saturday and half day for Sunday. Good, now I change the start date of my model to the 26th of August, and I want to add 2 exceptions. I want to avoid working a standard day during Christmas Day and also during New Year's Day. So to add exceptions, I can simply do like this. I click on plus here, and I can select the date which is associated to my exception. So I go down to December, and I think I will pick December 25th. Okay, it's a Friday. It would be a standard day in a classical, configuration, but I don't want to do that. And also I don't want to work a standard day in New Year's Day. I want to start at 10 o'clock. It's much more comfortable. So 1st of January, like this. So here I can select to work a half day instead, or maybe I can select not to work at all. But in this case, at least we work an half a day. And in this way, I define the 2 work exceptions. And now we are ready to go and add this information to the model, to the server that we're modeling right now. So this is pretty easy. We go back to the facility view, and now we pick server number 1. So now server number 1 has a property that is called capacity type. We always use capacity type as fixed. So the server is working continuously In reality, we don't want to do that. We want the server to work according to a work schedule. And now we need to define which work schedule do we actually apply. We defined a standard week with some exceptions, and we add it here. We also have opportunity to add even more workday exceptions directly into the property window, but I think if you use a table, a data table, this works better. Now I want to verify my model. So what I did is to drag and drop an item, a model entity, which is called DVD player. And I want to process this DVD player in the server. So I will change the inter-arrival time for the DVD player. Let's say that the inter-arrival time is random exponential and with value of 1 hour. And then we have a server which is processing this DVD player, and the time it takes on average is 20 minutes to process it, on a minimum of 15 and a maximum of 25. So we expect that the queue that is building up during the night will be sort of processed during the day. So here we keep it to 25 minutes and we run the server and see what happens. So you see, now we are at midnight, exactly midnight. We start the process at midnight, and the first DVD is sent to the queue for the server. But nothing is happening just because the server is off shift. The server will start elaborating and processing the DVD players only at 8 o'clock in the morning. If you look down here, we have some indication of where we are into the process right now. At this speed, we just run 7 minutes into the process. So if you want to simulate one entire week or one entire month, like in this case, it is going to take forever. So I will increase the speed factor to 100, just to see what happens. Now the time is running much quicker. As you see, the DVDs are piling up at the input buffer of the server. So now we are 3 o'clock in the night, and we have to wait until 8 o'clock in the morning to see something happening. Now it's 5:30, and pretty soon it will be dawn, and then it's time for the server to start working. Now it's only 20 minutes left. At 8 o'clock the server is activated, so it starts taking everything that has been produced during the night and processing it pretty quickly. So the queue is going down, and as you see. So we can visualize it even better in this way. We stop the simulation, we click on the server, and we add a status pie. So we add a status pie down here to visualize what's going on. So let's make it slightly larger so you can see. So the status pie tells the status of the server at different points in time, and aggregates the statistics. So a lot of time will be spent by the server being off shift. Sometime, 1/3 of the time processing, and sometimes there are no DVD players, especially before 5 o'clock in the evening, to be processed and the server is starved. So let's see now, if we run the model, what is going to happen. So we launch our model again. So it's 1 o'clock in the night and nothing is happening, and DVDs are accumulating at the input buffer of the server. Right now 100% of the time of the server is off shift. So this is totally correct with what we define in the schedule. So now we just wait a few seconds more until 8 o'clock in the morning, and now the server starts operating. So now you see the dark green bar is becoming much bigger. This part of the pie is coming closer to 33%, as we expect, and the server is elaborating quite a lot. Then there is a break between 12 and 1, and then the server starts to work again. So this is sort of a good way to verify that the schedule that you introduce is actually working as it should.